Wes, I think I've decided our show is called Weather Wise Guys, not because we're wise, but the people we have on tend to be wise, and so we get to learn stuff. What do you think of that?
I think we should call it Weather Wiser Guys, and it not be about us, but it be about the guests that we have on.
I'm all about that. Be a vessel for smart insight, really good observations, and we're being joined this week. Of course, I'm meteorologist Evan Chikvera in Birmingham. That's Wes Peary. He's in Kansas City. And this is Grady Dixon, a former professor of both of ours at Mississippi State University. He taught us synoptic and I think maybe one other course, right, Grady?
Yeah, weather analysis.
Analysis.
Can we all? Grady is also a meteorologist as well, right? Like, let's not is under meteorologist, professor, researcher, like everything.
Everything under the umbrella. I didn't exactly know. I figured I'd just let him kind of take the baton there with his.
Yeah, I spent about a decade at Mississippi State. I think I taught you two near the end of my time there. And for the last 11 years, I've been at a university in Western Kansas, Fort Hays State University. And so I live in Hays, Kansas, on I-70, conveniently located halfway between Denver and Kansas City, which is, if you know anything about the area, it's not all that convenient.
So can you explain the geography there? Is it flat?
It is smooth, mostly. It is treeless. It looks flat because there's so few trees. But it's not totally flat, but boy, it sure feels like it when you're making that drive. And it's also slanted, which you can't really tell, but that's really important for all the weather stuff that especially Wes has to deal with.
I think Kansas has this misnomer of being the flattest state in the country.
Not true.
It's not. It's not Oklahoma, is it? Who is it?
Delaware.
Whoa.
And Florida, and I think Delaware has the highest point, but I think Florida is the flattest on average, something like that.
Okay.
Look at that. We
sense.
are, 2 minutes in, and we just learned something I didn't think we'd cover today.
There is an actual research paper by an old grad school colleague of mine who's now at University in Colorado in Colorado Springs, and he used a digital elevation model in LiDAR. He LiDAR'd a pancake, basically, and tested whether or not Kansas was flatter than a pancake. And the answer in that case was yes, but that's because the pancake had a tremendous amount of topography if you scaled it to the size of the state. It's kind of interesting.
That's fascinating. I had no idea.
Oh, that's good information.
My internet's not going out, is it?
Yeah.
I'm gonna lose my mind. If it starts to get bad, I'll hop off and hop back on.
All right.
Okay, so the reason we're joined with Grady, in addition to reminiscing, so me and Wes, we broadcast. Our job is to communicate, but we learn a lot about how things work and how to communicate that from researchers. And Grady does a ton of that. And one of the topics we talked about back in, I want to say early this year, Wes, before severe weather season, was Tornado Alley and Dixie Alley, respectively. Is that region shifting? What is that region? What has been the trend? Why has it been the trend? And what can we expect moving forward? Tons of questions, and hoping to get some answers, as we move forward.
Yeah, I get that question a lot. I remember you all both probably had Dr. Charles Wax for some class at Mississippi State, maybe intro to meteorology. And I remember way back 30 years ago when he taught intro class to me, he introduced that idea of Dixie Alley. I'd never heard that term before. And it was pretty old at that point, but not widely used. The idea was that the South, Dixie, they get tornadoes, maybe more than most people realized. And it was usually in a different time of year than what most people expected. Everybody thought tornadoes, they think of Texas, Oklahoma, Kansas, and that's late spring. But the Deep South would get tornadoes during the cool season, during the fall, sometimes even December and January. And so they called it a whole different place. They have Tornado Alley in the plains, Dixie Alley over in the South. Now it's a much more common term, especially after 2011 when you had that huge outbreak that was centered really on North Alabama. But just a lot of high-profile events. And with climate change and a variety of other things going on, it does look like we're getting more and more tornadoes in that area, or at least recording more. Maybe we're getting fewer in the Great Plains. So the idea of a shift is not, it's not an unfair question. But I suppose we're going to dive into that.
Yeah, so let's start here because me and Wes have kind of grabbed some numbers and kind of started at a very basic standpoint that I think a lot of people's stance would be with respect to this, comparing an easy, hey, this is a reason why it's moved. Here's the numbers. So I'm going to pop up, Wes, this is the info you sent me. So you can explain this and kind of start with kind of your thinking and what this data is showing.
So I took a database here that has all the tornadoes from 1950 to 2024. And I think this is so this is 1950 to 2020. This is kind of the first 35 to 40 years of that. And you look at the different colors. Blue is EF0, green's EF1, yellow is EF2, and red is EF4. For those of you that are just listening to us, there's a lot of EF2s, a lot of EF3s going on here, and across the regular tornado alley across the southeast, Iowa, Illinois, and then once you get into the Rockies and across the West Coast, a lot of EF0s, very small, brief tornadoes. And so you can kind of make out the alleys here, if you will, of regular tornado alley and southeastern portion of the United States, like quite easily.
Wes, did you mention that this period is 1950 to 1985?
Yes. Yes. Okay. Thank you, Evan. So this is early on in overall weather technology and technology in general. But this next one, now we're taking 2024 through, I think it's 85 to 2024. And one with a bunch of blue.
Oh, go forward. There you go.
Yes, that one. First, the amount of EF0s is like the biggest thing that stands out to me, and they're all over the place. Like even in California, the valley full of tornadoes, Texas full of tornadoes, Florida full of tornadoes. So there's EF0s all over the place, and there's not as many of these yellows and oranges that signify EF2s and 3s, and I barely see many EF4s or EF5s. And so just immediately looking at that, my thought process is we are seeing a lot more tiny tornadoes, or there just aren't any big tornadoes really happening anymore, and they're all small.
Very interesting. Grady, you want to say something? Yeah, I want to point out that there does seem to be some events missing on this most recent map for sure. So it doesn't really matter. The point that you're making is still valid. But if somebody's looking at this and saying, I know for a fact there was an EF3 or 4 in this place in the Great Plains, they're right. There's a lot of events that are missing on this particular map. But the message that, one, there's a lot more EF0 weak tornadoes in the later period, and that there are more events clustered in the deep south than there were in the earlier period. Those things are true in every data set we can show, and this does show that.
I think, coming from Wes's standpoint, I kind of took a simple approach to this too before, realizing kind of what all goes into it besides just an area. So I grabbed data going back to 1950. Sorry if this is tough to see, but I labeled so Tornado Alley is going to be Texas, Oklahoma, Kansas, Nebraska, and Dixie Alley is Arkansas, Louisiana, Mississippi, Tennessee, Alabama, and Georgia. So those, I'm sure those definitions fluctuate. I looked at some that include South Dakota, some that include Iowa and Missouri. Some, there's different variations, but I think this gets the point across. So from 1950 to 74, Dixie Alley had, about 2,900 tornadoes reported. 75 to 99, that following 25 years, that number almost doubled. And then 2000 to 2023, which is where my data set stopped, it's basically close to 180% of the previous 25 years. So that is a huge jump. Obviously, there was a tremendous outbreak, a couple of them actually, in the Deep South in that time period. But I look at Tornado Alley's numbers, and they're just pretty steady. They increase, but no major fluctuations. I look at Dixie and I'm like, what on earth has caused that spike, you know, in that time frame?
Yeah, it's funny. I give a lot of talks about tornado climatology, and I occasionally give talks just about climatology in general and climate change. And I'll show tornado data. I'll show trends like this and say tornadoes are being affected by climate change, but maybe not in the way that you think. And this graph is not a climate change signal. This graph is a population, education, and technology signal. Mostly. There are other things at play as well. But largely the idea is that we have gotten better at detecting these things. And, in some parts of the country, like Western Kansas, we've always been pretty good because they mostly happen during the day. There's not a lot of trees to block the views. The storm structures that usually produce tornadoes are the sort that make it easier to view tornadoes. Contrast that with tornadoes that happen farther east, and especially in the Deep South. They tend to be clustered in multi-cell storms, blocked by lots of rain. There's lots of trees. Sometimes there's more complex terrain. They happen during a time of the year when it gets dark early, so they're more likely to happen at night. So there's all these reasons why we're missing a lot of tornadoes. And there were a few key moments in history that changed that. One was introduction of Doppler radar. Suddenly we started finding them a lot more. That even helped in the plains. And then it was the internet, widely available in most homes. You could report these things. And then smartphones. And then another radar and technology improvement with the dual pole. I'm not sure if y'all have talked about that on your podcast, but it's just a better, sort of higher resolution version of Doppler radar that helps us identify character shapes, so to speak, of the raindrops, and we can compare raindrops to things like non-weather targets like debris or animals. Long story short, it helps us be much more effective in diagnosing tornadoes with radar, where instead of in the past, even with Doppler, you had to see it in person or see the damage in order to be sure if a tornado was happening.
I didn't realize that Doppler radar, until I was looking back at it before this, doesn't have velocity data like the newer dual pole. So unless you have a classic signature, that's what I was going to ask you about, Grady, was like, for them to go survey stuff, the National Weather Service, obviously they have to have a signature or a damage report. But say it's an embedded MCS, and you just don't see anything that stands out. Could there have been several of those, like lower end? We get tons of MCS, little spin ups in a line here that would go unnoticed if not for radar technology and honestly a huge group of sky watchers that we have in our network.
Yeah, and I think you kind of stepped on your own words there, but I want to clarify. Doppler radar became pretty widespread in about 1992, and Doppler does provide velocity data. So that's...
I'm sorry.
If you've got a big cluster of storms and there's no classic hook echo, that Doppler velocity product will show you that there's rotation. It doesn't tell you there's a tornado, but it at least tells you where there's some rotation and gives you an idea of where to look for possible damage. But prior to 1992, you're right. There was no velocity product. All you got was reflectivity. And if it was like you said, a cluster of storms, a QLCS, non-conventional thunderstorm or supercell, you weren't going to be able to spot it. And so you were relying 100% on damage after the fact, because if you couldn't spot it with radar, you probably couldn't spot it in person most of the time either. So that's a big chunk of our history. We love to go back to 1950, but these tornado data have lots of challenges, and we don't want to just throw the baby out with the bathwater. We want to still figure out some things from these data, but we have to acknowledge that they are quite imperfect. And then prior to the advent of Doppler radar, there was another major pivot point in the record, and that was in 1973. That's when the Weather Service started using the Fujita scale to assess tornado strength according to the damage. they started doing that for those events. Prior to 1993, that we didn't have the Fujita scale. Ted Fujita just created it in the early 1970s, and so the ratings that we have prior to 1973 were created from his graduate students, and they would just go back through old newspaper stories about major events, and they would try to classify the storms according to those photos. So lots of problems with that. You can imagine looking at black and white photos, and of course the photos are going to be of the most severe part of the storm, but that's how ratings are done. It's based on the most severe part, most severe damage of the storm, but you don't have much context in terms of building quality or anything else. And what you see is that in 1973, there was a big drop in the average rating score of these events because you just were able to be a little more accurate, we think.
A couple more things that come to mind is dual pole was, from what I'm seeing, completely implemented across the National Weather Service in 2013. But, like 2010, 2011, I think the cities that really needed it, the weather forecast offices that really needed it were starting to use it. In 2007, that's when the Discovery Channel started airing the show Storm Chasers. That's when it really, I feel, we had Twisters. Like, I forget what year the movie Twister.
1996.
No, okay, thank you. I was 4.
Come on, Wes.
So you had Twisters, and then you had Storm Chasers. And so, like, for me, the Discovery show Storm Chasers was much more of like a storm chasing pinnacle moment, like culturally, than Twister. And so I feel like you have, a decent little 5-year period here in which you're seeing probably an increase of storm chasers in general and our ability to see these smaller tornadoes. It was like, is there any, jump in the data within that small period that you've noticed, Grady?
Yeah, but it's going to be associated with smartphones as well. And the story I like to tell all the time is, especially out here in Western Kansas, but actually the first tornado I ever saw was in Mississippi, and it was this relatively large field, maybe 1,000-acre field with no trees. And I knew that was the only place I had a chance of seeing this tornado that was moving toward that area. And so I raced ahead of the storm, went to that field and said, if it crosses the field, I'll see it. If it's in the forest, I'll never see it. And there were only 2 people anywhere near that field. It was me and a farmer that was just doing his job in the field, driving his tractor. And the tornado, sure enough, came through the trees and crossed the field, and he and I stopped. We both had a kind of shared moment from 200 yards away. That was 1998. I'm sure he went home and told his family, hey, I saw a tornado today. That was really pretty cool. I doubt he called the weather service because he would have had to get a phone book out. He would have had to have known that the weather service existed, which I didn't at that time. And he would have had to look their number up in the phone book, dial the phone out of his house. He wasn't going to do that. Now, if that exact same scenario happens, he and I both are streaming it live from our phones. And if anybody cares about it, millions of people will see it within an hour. And truth be told, there probably would have been 24 other people standing on that same stretch of highway looking at the storm because they would have had radar on their phone that told them where they could have gone to see it. So all that stuff combines together, and it's just a little bit each time. But the things like dual pole, because that's infrastructure that our experts are using, our practitioners, I think that probably had a much bigger effect individually than even the smartphone or the internet. And Doppler implementation was probably the same way.
I think when I misspoke, I think I was trying to say the WSR 74. Was that the one right before Doppler?
Yeah.
Okay. And then, all right. So, yes, I got a little crossed up there. So don't mark me down too much. I'd still like to get an A after this. So Grady's done, obviously, Wes and I have talked about this. And from a very broad, wide lens, we can show you numbers and say, hey, over the last 25 years, there's more across the Southeast than there is over the plains, or a greater jump in numbers, 25 years over 25 year over year. But Grady's done a much deeper dive into it's not just how many are in a state. There's a lot of other parameters you looked at. I'll let you kind of take it. This is your stuff.
Yeah, I can kind of give you a history of how I worked through the research that I've done on tornado climatology. And, so I got my bachelor's degree in 2000, and I was in graduate school when this paper came out that we're looking at now. And this was a huge paper, still is a major paper in the history of tornado climatology. And Harold Brooks, researcher at the National Severe Storms Labs, he is co-author. Chuck Goswell, extremely famous meteorology professor and storm chaser. They did an analysis of tornadoes in the country. In that time, their data set ran through from 1980 through 1999. And on the left, they have a very reasonable image of where tornadoes initiated. And this was the way it was done back then. And the track of the tornado is important because that's where the damage occurs. But from a meteorologist perspective, there's something so special about that moment where you go from not having a tornado to suddenly having one. That's what we all wanted to learn about. What makes that happen? And so a lot of research focused on that. Plus, it was a lot easier to just plot points. Believe it or not, even in 2003, it was kind of challenging to do something quantitatively and objectively using paths or even tracks of tornadoes. So all the research just used the initiation points. That's totally fine. And when you do that, this is what the map showed. And it was maybe not that surprising to folks that study tornadoes. The hotspots were the Southern Plains, Northeast Colorado, Florida, which a lot of folks maybe weren't so aware of if they weren't in the field. Those tornadoes are much weaker. Likewise, the ones in Northeast Colorado typically are. But the big area that you expect tornadoes and what became Tornado Alley is on the right. And the way they arrived at that is that region has a very predictable season. So the peak of the season in that highlighted area moves less than about 10% per year. So if you're trying to find the most active day every year in Nebraska for tornadoes, it's going to be within a few days every single year. If you want to try to find the most active tornado day in Mississippi or Alabama, good luck, because it varies tremendously. It could be in October and any month thereafter all the way through April or May. There is not much consistency or predictability in the season. And so they used that as a component. And it made a lot of sense because they were ramping up, they being weather researchers at the time, for this big federal project to go out with lots of research in the field, lots of radar trucks and little instruments you'd put in the paths of storms. It was called the Vortex Project. It was Vortex 2 that was coming up. They had the first Vortex in the 90s. And this was helping researchers understand when and where do tornadoes initiate and where are they predictable, where are we most likely to see them. So the shaded area on the right is one version of what you might call Tornado Alley, and it's based on frequency and predictability. But, like you and I have said, if you look at the data, clearly tornadoes happen well beyond that area.
I was a little surprised, I guess, at that bullseye in Northeast Colorado. I would have pegged that a little bit further to the east, but I guess that makes sense with the change in topography, the dry line, and everything else there. But that's another thing I didn't think about is the initiation point, and then where they go from there, which is such a huge part of the track. It doesn't necessarily matter where the inception is; it's what follows.
Yeah, the Northeast Colorado area is kind of interesting. It's largely landspouts, and it's not conventional dry line sort of initiation like you would have on the high plains. It's not so much the Rockies either. Really, it is the Rockies are playing effect. But if you look up the Denver cyclone, maybe would lead you to the right place. If you think about the topography that is east, that is perpendicular to the Rockies. So if you ever driven from Denver to Colorado Springs, you go over a ridge and you're not heading toward the Rockies. So that's called the Palmer Divide. And if you go north, there's a smaller but similar ridge that is right along the Wyoming-Colorado border, and it's called the Cheyenne Ridge. And so it creates kind of a C-shaped right around Denver. And that creates a lot, relatively speaking, low-level vorticity that just kind of hangs out in that area on a lot of storm days. And otherwise, severe storms that would have no real chance of being conventional mesocyclones, they'll move across those little areas of vorticity and spin up lots of landspouts. And so that's why they're typically very short-lived, very weak, but they happen a lot.
I did not know that.
And they're super pretty. They're like very tall, high-based, not even that like violently spinning compared to a tornado, but you're just like, this is freaking sweet just to witness.
Yeah, absolutely. They don't move very fast. They don't impact much. Exactly. They're kind of the perfect tornado in that way.
Random sidebar before you continue. So when you talk about LCLs, because I've had this conversation with people before, is there a maximum, height where they can't occur, or a minimum, a lower point in the atmosphere where tornadoes cannot go through that development period? Has that been looked at? When I was in Dothan, we were so close to the Gulf, and the LCLs were so much lower, but you get these tornadoes versus in other places, and I've never been able to pinpoint it, but it's just something I've been curious about.
Never say never. I mean, there's a spectrum, and you have high probabilities, near certain values, but every year there's these extremely photogenic tornadoes that you see, and you think, oh my gosh, it's a low precipitation supercell. The base feels like it's 3 miles high. Like, how in the world did it create that long tornado? How did it make it all the way to the ground? So, in theory, sure, there's probably a cap, but never count it out if the conditions are right otherwise. And certainly you can have tornadoes in fog. I mean, like the LCL can be dragging the ground. I've seen plenty of wall clouds that were dragging the ground. And the question became, is this a mesocyclone on the ground? Is there a tornado? And does it matter if the mesocyclone is touching the ground? Those sorts of conversations happen a lot. That's when you're out there and you're trying to show, I take students out on these storm chase field trips, and you're trying to explain to them the processes that are happening. And then there's people around you on the side of the road yelling, wedge, wedge. And it's like, well, not exactly. It's still not rotating that quickly. It's a mesocyclone, but yeah, I guess it is kind of touching the ground. Like, you don't want to be, you try not to be absolute about these things, because we're naming them the best that we can, but it's all just a spectrum of spinny things, and it will make you look like a fool if you act like you know it all. That's for sure.
Oh yeah.
No, I would love to be watching someone's like live tornado stream, and then I'll just hear you off in the distance yelling at this like overly exuberant like 20-year-old that's streaming on YouTube, like correcting them. That would be so great.
Yeah, that's a great way to ruin the moment for everybody. But if we go back to my timeline of research here, so Brooks and Doswell and Kay had that paper that came out in 2003 and kind of set the mark for what we how we saw the spatial pattern of how tornadoes initiated. And then a grad school colleague of mine, Walker Ashley, he and I got our masters together at University of Georgia, and he's been a professor at Northern Illinois now for, my goodness, 20 years or so. And he's a prolific researcher, does great stuff, especially with severe weather. And so he had a paper that came out in 2007, and it was focused on tornado fatalities. And so the series of figures that he has here, you can see at the top, it's the number of tornadoes. So it's tornado initiations. And this looks similar to the Brooks and Doswell paper, but not exact. And Walker's period of record here is 1950 through 2004, so much larger than the Brooks paper. And then the second image is the strong tornadoes, F2s or greater. And you can see there's a little bit of a shift south and east. And then for C, the killer tornadoes. And A and C, in my opinion, most people in the weather enterprise, when this paper came out, focused on A and C and said all the tornadoes are occurring in the plains and all the fatalities are occurring in the Mid-South. What's the problem? Clearly the Mid-South is broken, or the tornadoes are different, or that was the question, is how do we reconcile the difference between these two? And at that point, a lot of people started getting involved and asking these questions. And a lot of people got their career started studying severe weather. I never talked to Walker about this, but he probably created a lot of people's careers, especially social scientists, because at this point we started saying, maybe this is not a weather problem. Maybe we need to ask people that are not pure, quote unquote, hard scientists, but ask the social scientists. This was a pretty important paper.
Yeah, the social science is a huge help too. I know it has been for me because I get lost in our little world of weather, and we look at it 24/7. But to the common person out there, who doesn't necessarily understand, the reason of wearing a helmet or going to your safe place, having multiple ways to get warnings. I've learned so much from these people that didn't even cross my mind because we get so hyper focused on weather. So that's cool. This was kind of the start of that movement.
Absolutely.
What else you got, Evan?
So this paper came out in 2007. Oh. I'd say it was somewhere about 2010 when I had a graduate student, Jared Allen. I'm not sure if y'all ever knew him. He got his bachelor's and his master's at Mississippi State.
That sounds familiar.
It does. I can't picture a face, but sounds familiar, the name.
Yeah, he's a tall fellow, works for the Weather Service in Cheyenne now. And so he was working on his master's at Mississippi State. And he was really focusing on GIS in his master's. And he came to me. He'd been doing a GIS project looking at tornado climatology. And again, I think Jared, I know he did. Jared had gone, Walker and I used to chase storms together every year after the spring semester was over. And Jared had gone along with us. And so Jared was really inspired by Walker's work, and he was doing that for part of his master's thesis. And he was working with a professor that showed him how to actually use the full tornado tracks, not just the initiation point. And Jared came to me when he was looking at some of his results with the tornado track data. And he said, I think I'm doing this wrong because all of my bullseyes are popping up in places I don't expect. And so we dove into it. And if I remember correctly, I mean, there were some problems with the algorithms that he and his GIS professor had created. But ultimately, the patterns didn't change. I mean, it was real. And we came at it from several different angles, trying to prove ourselves wrong because we didn't believe it. And you can see this map. This is from a paper that we eventually ended up publishing in 2011 in the Bulletin of the AMS. And I guess, the image on the right tells the story. This is two counties that people may not think are comparable in their tornado risk. On the left, it's Oklahoma County, Oklahoma. That's the middle of the state. Oklahoma City is there. It looks probably like what you would expect it to look like with tornado paths and points. The other one is Smith County, Mississippi. Unless you are from that area and happen to be a fan of watermelons, because that's what they're known for, is selling the best watermelons in the state. Awesome. Nobody's ever heard of this place. And if I ask you, which place would you feel safer to build a home? The answer is neither. With all apologies to the Chamber of Commerce in both counties. But
you gave him love for the watermelon. It's okay.
Yeah, that's right.
I think it's even.
Compliment sandwich.
But Smith County looks quite a bit worse. It's fewer events, but they are covering more ground. And that ended up being what drove the results of this paper. When you look at the full tracks and not just the points, the picture changes. And it's not where do the most tornadoes occur. It's where are you most likely to be affected by a tornado? Which area has the most ground being covered by tornado tracks? And the map on the left shows you there's bullseyes there in south central Mississippi and just northeast of Little Rock, North Alabama, of course, through the Great Plains, near Grand Island, Nebraska, Dodge City, Kansas, Oklahoma City. And there was criticism of this paper, somewhat rightfully so, because the way that we did the smoothing created these unrealistic bullseyes. You see all the research that followed this paper, and the patterns are much broader. Which you smooth it out so that you're not letting one or two events really drive the narrative. But the reason we chose to smooth it this way is because of the blue shading. It's the part we totally did a bad job of communicating the point of this paper. You can see the title of the paper is Dixie Alley an extension of Tornado Alley? And I see I've got a typo in the title there. But we were trying to see if they were actually even different. Our hypothesis was that it was all just one big cluster. And the blue area essentially shows us that there is no clean break between the two. And so if you were looking for the area that had the absolute highest tornado risk in the country, okay, it's probably Oklahoma or Mississippi or somewhere. But if you're looking for where are there distinct alleys of risk, there's none. And there was the master's thesis that this fellow did, I think at maybe University of Akron or something years ago. He did a great job of doing GIS analysis of tornado tracks, and he had identified like 5 different alleys. There was one in Indiana, one in North Carolina, there was the Deep South, there was the Plains, and it's just an idea of statistically, can you separate them? And we did much more in this paper than this image shows, but statistically we found it's all the same. Everywhere east of the Rockies and arguably west of the Appalachians. But as you can see, even coastal Carolina is a part of this. It goes all the way from almost the Outer Banks to the Kansas-Colorado border, and it's all one big area. So what we were trying to say was there is no Dixie Alley. And you know what? There's probably no Tornado Alley. Instead, I became the Dixie Alley guy, and it just like reinforced that term, which again tells me that I'm maybe a decent researcher, but I'm probably a bad communicator, or at least I was in 2011. I hope I've learned some since then.
No, I'm really surprised that it was Smith County that is the big county. And for reference, those of you that don't know Mississippi geography very well, Smith County is southeast of Jackson, which is located generally in southern Mississippi. I was thinking it would be like Yazoo County, which is located northwest of Jackson, like immediately northwest of Jackson. Because there have been notable tornadoes like the Yazoo City tornado, very big. But generally north of Jackson, like wasn't that where the Rolling Fork tornado was? Was it on the north side of Jackson as well? And
Rolling Fork was just west. It was within one county away from Yazoo County, like you're talking about. Yeah.
Yeah, and so obviously this paper doesn't take into account the Rolling Fork tornado, but there, like Mississippi has its own tornado alley, and it's like that is the last place. I would rather live in Oklahoma than that part of Mississippi from a tornado standpoint.
Yeah, and there's a lot of things that go into play with that particular Smith County thing. Smith County's pretty close to the radar, which is kind of east of Jackson. It's pretty forested. It checks a lot of boxes for a place that you would be missing tornadoes, except for the proximity to the radar. But anecdotally, I tell you, every time there's an outbreak down there, I always just check to see if Smith County was able to ring one up. And almost always, it seems like that's the case, which is a terrible way to do science. But the point is, whether it's Smith County or just like a 5-county cluster in and around Jackson or whatever, the point remains is that it was in a place where nobody expected. And now, if you think about that work that Walker had done, the idea that there's this big bullseye of fatalities from tornadoes over the Mid-South or the Deep South, it makes a lot more sense.
Interesting.
Yeah.
Now, that's not everything. Certainly, Stephen Strader is a great researcher at Villanova University. He's done a ton about home quality and development patterns. We just talked about the value of social science researchers in tornadoes. Absolutely. All of that stuff matters. If you can survive most tornadoes in a reasonably well-built home, but boy, if you're in an automobile or a mobile home, you are in trouble, almost regardless of the strength of the tornado. And so those are the sorts of things that we just cannot say enough. And that's what a lot of other researchers have shown.
Yeah, I was going to ask you about mobile homes, because we found out after 2011, I know specifically here in Alabama, how many people live in manufactured homes, which great homes, but not when there's a tornado coming through. And I don't know the ratings by state, but I know I've lived here now for 11 years. Mobile homes are very popular. And every time we've got a fatality, since I've been in Birmingham, almost every fatality is related to a mobile home. It could be straight line winds, it could be a tornado. Does that skew the numbers at all, or does that contribute, I guess, to maybe this bullseye?
I think it contributes some, for sure. But there's plenty of states that have more that have more mobile homes than Mississippi. Mississippi doesn't have a lot of anything. There's just not many people that live there compared to other states. They have a high percentage of mobile homes, but there's still not a lot of them. But like Stephen Strader has shown, and Walker has done the same work as well, it's about the development patterns. If you drive through the Great Plains, it is little bitty towns surrounded by ag, and nobody really lives in those crops. It's just tiny clustered towns. If you drive through Alabama, people live all over the place. They're just spread out. They're sprawled. They're not clustered into towns necessarily. So if a tornado cuts a path across western Kansas, odds are pretty good it won't hit a home. That is not true in Alabama. There are very few places in the deep south where you can, run a line for 5 miles and not hit a structure. And probably you're going to hit a mobile home in almost any location you choose a 5 mile or 10 mile path.
And from the broadcast perspective on that, if a tornado is occurring, in my viewing area, but I'm pretty certain there's really no one there that could be immediately affected by it, I'm not going to get in a huge rush to jump on TV because there's just nothing to really warn people about. And that's probably an even, stronger, that happens more frequently probably in like Nebraska and Kansas, where it's even more rural than my parts of the state.
Yeah, the Weather Service is going to always warn, some people like to keep track of the tornado warnings that come out, or severe storm warnings that have 0 people in the polygon. But who are you actually warning? But you have to, because people drive. People drive through unpopulated areas. They visit them. You still want everybody to know. That's different when you're on TV, because the odds are, if you're in the sand hills of Nebraska, you might be passing through, but you're probably not watching the news on your phone while you're doing.
Nope, not at all.
But yeah, so that paper came out in 2011. Coincidentally, it was released the same week as the 2011 April 27th tornado outbreak.
Wow.
And so it got a lot of press. I think USA Today had done an article about it the day before April 27th outbreak.
Wow.
So that really, terrible event, but fortuitous for public awareness, those two things happening simultaneously. And boy, I tell you, since then, there's been a lot of great research on tornado climatology. And, we just will touch on a tiny bit that I've been involved with here, and then a couple of other colleagues. But there's been a lot of folks doing stuff that we won't have time to go through. One of the next papers that I worked on was with a colleague at University of Alabama in Huntsville, Tim Coleman. And there's 2 images here. We did things a little bit differently. We looked at tornado data only since 1973, which is when they were rated in real time instead of going back looking at newspaper clippings. We also looked only at the strong tornadoes, F2 or greater. And on the left, you have this pretty ominous bullseye that runs from about Jackson through Huntsville. And when we saw this at first, we thought people aren't going to buy this. They're going to think this is 100% a relic of the 2011 outbreak, because that was the last year of our data. But if you take out 2011 completely with all of the long track tornadoes you had there, okay, sure, you get rid of the dark red, but the pattern is still the same. The message is still, if I had shown you the image on the right without knowing the image on the left existed, you would have said, gosh, okay, deep south, Arkansas, Tennessee, Alabama, Mississippi, like that is the place where the most strong tornado tracks intersect each other and cover more ground. Of course, it's not like we're looking at Oklahoma or parts of Nebraska or Iowa and thinking, yeah, they're off the hook. Not at all. There's still lots of tornadoes that happen in those areas. And the thing that I liked about this paper, again, not the best communicator at the time, but hopefully getting a little better, it's not an alley. It's a very large area that's not linear or restricted to one geographic area. It's everything east of the Rockies for the most part.
So when you looked at this and you're looking at this data, did you have a criteria for what you looked at, how long it was on the ground, the tornado path? Is that what you were saying? Or is that a radius from any given touchdown?
The only criteria we had for including tornadoes was their rating. So it didn't matter their length. Okay. But, most of the time, if you have a strongly rated tornado, it's gonna have some distance to it. It's rare that you have a stationary tornado that gets a high rating. So these all had pretty significant paths, but they varied widely. And then the way that we the reason that these maps look smoother, have larger bullseyes or whatever than the original map, is just because if a tornado goes down your street, down where you live, it travels right down your street. You don't think that the next street over is safe and that your street is the dangerous tornado place forever. You say, well, a tornado went through my town, and you know what? Actually, 4 tornadoes have gone through my town over the last 30 years. Everything around us is at risk. So you need to find a way, since we've only got a few decades of data, to say, as you get away from this tornado track, your risk may go down, but we're going to decrease it very slowly. And so, like in this case, I think the degradation rate is maybe 300 kilometers, which means that if a tornado went through your town, then for the purpose of this analysis, places 300 kilometers around received a tiny little bump in their tornado risk because of that particular event. And over time, you accumulate all those tiny little bumps, and of course, the larger values where the tornado goes right through, and this is what you end up getting. If we had 10,000 years of tornado data, we wouldn't need to smooth them. But since we only have a few decades of even quasi-reliable data, we've got to use smoothing.
How? Go ahead, Wes.
Just like always, my initial reaction when I see this is that, all right, these little maximas, and for those of you listening, I'll kind of describe this, these maps. We're looking at a map here, and it has like a hot zone from Louisiana through Mississippi and Alabama, a smaller, maybe not a hot zone, but like another notable area there near Oklahoma City and Tulsa, one near Des Moines, and another across southeastern Nebraska and like north central Kansas. And so the way I've just described that, most of those places are near where people live. So stuff is being hit. However, this one bullseye near Kansas and Nebraska, that is very low population. And so it's really interesting how like that ended up on the map when there isn't that much stuff there to hit at all.
Yeah, we've talked a lot about that over the years. You're right about the population. I mean, there's so many studies showing that proximity to towns and proximity to interstates will increase your odds of having a tornado. It's not actually atmospheric. It's just the presence of people. And the bullseye over Nebraska is somewhat famous in tornado research because of something called the Night of the Twisters. It was a real event, but there was a terrible movie made about it if you're really bored some night. And there was essentially a somewhat stationary supercell right over the town of Grand Island. And if I remember right, it was actually like propagating on a boundary backwards, like it was moving southwest or something like that. But it was producing tornadoes cyclically. And so I forget the exact numbers, but I think it was 7 or more tornadoes went through the town of Grand Island that night. It was unbelievable. And so I think that may be one reason that there's always a hot spot there, because Grand Island is just on the northern side of that little hot spot circle, so to speak. But there's also I-80 runs through there. There's a pretty big 4-lane highway that goes from Wichita up through Salina and then goes all the way up to I-80 in Nebraska. So there's more people there than you might think.
If you had 50 more years of data I know you mentioned, thousands and thousands of years, what do you think could most likely change with this? What do you think we could discover or uncover, with the way trends are going now? Because I'm always curious. We have the numbers, we have a sample size. Where are we headed?
Well, so I thought you were going a different direction with that. If let's just say we had 100 years of good data. So 1950 were perfect. We caught every tornado and we rated it perfectly. And we did the same thing every year since. And if we had 100 years of that, what would we find? I think we would see mostly what we're starting to see, which is that the Deep South has about the same number or maybe fewer events than the hotspots in the plains, but the risk is much higher. But we would also see some places that we have not even been on our proverbial radar, like northern Arizona. Nobody is going into the deserts and the mountains, rugged, much more remote than western Kansas, to go see if an EF1 did a little damage to a cactus. I mean, they're just not looking for it. There's nobody who lives there, so to some extent, people don't care. I think we probably have something similar in the Appalachians, not as much, but we'd have more than we see here. And also Southern Canada. We'd have a better record of what's going on there. And it wouldn't look like our risk just abruptly stops in North Dakota, because that's not true. But the other side of your question you actually asked is, into the future, if we go 50 more years, what do the trends look like? Oh, man. I can't be wrong, because I'm probably going to be around 50 years from now for y'all to tell me I was wrong.
Can't be wrong yet. That's the beauty of a forecast. It's right. Not wrong until it's happened yet.
I think we're going to see continued drying from a hotter and drier Southwest, which is going to cap off the Great Plains. And so, long story short, there's this overly simplified concept that the 100th meridian, 100th degree line of longitude, which runs, if you look where the western side of Oklahoma, not the panhandle, but the western edge of the fat part of Oklahoma, just to the east of that is about the 100th meridian. And a lot of folks say that's the separation between deserts to the west and more humid areas to the east. That is generally drifting to the east with a changing climate. And with that shift, with that drift, we will probably get fewer tornadoes in the Great Plains. We're not going to turn it off. The Great Plains are still a wonderful tornado-making machine due to their topography. But it's just going to happen less frequently. And we'll probably start seeing more tornadoes because maybe we'll detect them more, but also because they're happening more up the Ohio Valley. So not just in the Deep South, but through Kentucky, into Ohio, maybe even into Pennsylvania. So not major, not dramatic shifts, unless you're a homeowner in one of these places, or unless you're an insurance company. Those are real conversations. I get asked to come speak at insurance adjuster conferences on a pretty regular basis, and there was a lot of news last year about insurance companies getting out of the state of Iowa. You've heard about it in California. Like, that seems to make sense to people with wildfires and kind of the expensive homes on cliffs and the floods and stuff like that. That seems understandable. But Iowa, there's so much severe weather there, the insurance companies are saying they're not gonna cover homes.
You know what I learned about insurance this past spring? So two separate events. One of them, I was on the air for 12 straight hours, came home to my fence knocked down, and I'm thinking, oh, great, insurance claim, new fence. If it had been as simple as one bolt from the fence post into the mortar of the brick, it had been covered. But it didn't touch the house. It wasn't connected to the house, so it was not covered. And so $4,500 later, we got a new fence. And then a couple weeks later on that new fence, a tree fell, took out a panel of the fence, and then also went into the siding of the neighbor's house. So now the weatherman's got trees falling on people's house. Bit of a...
The important question is your new fence bolted to the home?
Yeah, I had him put one carriage bolt in there, because literally some guy came out, some adjuster, and told me that, and I said, the things you don't know, but
hey, as long as you're learning from it, right? It's not wasted.
Oh, yeah.
Hold on, if you attach the fence to your house, it's covered by insurance?
At least in Alabama. He said if this was anchored into the home, which out there's brick, it would have been covered because it's considered part of the structure, part of the domicile. But it wasn't.
Good use of domicile.
Oh,
I'm making a note.
Hopefully earning some credibility back from my radar kerfuffle.
I just made a note to see if that also works in Missouri, if I just need to attach my fence to my house somehow.
Go look. It'd be worth it. I've learned more in my 4 or 5 years of home ownership than I ever did living in my house. I have so much more appreciation for things now.
That's funny. Man,
I was just about
the slide here. This is related to that question of where do you think we're going in the future? And so these guys, Victor Gensini is a professor at Northern Illinois University, and here's Harold Brooks again. The very first paper we showed in this podcast was his. He's at National Severe Storms Lab, they put this paper out back in 2018, and there's two different sets of variables here on these maps. The one on the left is looking at a metric for assessing the ingredients for tornado prediction or tornado production. So I guess I don't know much about your audience. Like, how much do they know about STP?
We have a handful of people who know that that's a parameter that we look at. We have some people that know a pretty good amount.
Okay. But the significant tornado parameter is what it stands for, and so this is a modeled product that's heavily used, and they used that back to 1979 through 2017, and what they've shown is that the conditions for tornadoes, according to STP, have been much less common throughout Texas and the Southern Plains and even parts of Colorado over that period. And if you look, everything in red and yellow, those are increases. And you see, for sure, a hot spot there over the Mid-South, Memphis down through about Tuscaloosa. And of course, lots of areas around it showing increases in the frequency of high STP values. Now, this is not reality. It's a model. But if you compare that to the right, that is actual tornado reports, and you see the same pattern. It's not exactly the same because, of course, we don't have reports everywhere. We probably missed some, blah, blah, blah. The models are going to have a better resolution. But
that's pretty good, though.
The pattern is the exact same. Yeah. So you want to know what's happening? Where are we going in 50 years? This is probably a hint of what's going to happen.
Good stuff. I don't want to miss out on any of your other stuff here. I don't know if there's any of these you want to talk about to kind of further anything else, or kind of tie up loose ends here, kind of just, I guess.
Yeah. Well, so we started asking whether or not there was a real shift. And yeah, the answer is probably so. Is it a pure shift, or is it that we're just finding more tornadoes in the east while we're also losing them due to climate change in the west? That wouldn't necessarily be a shift. We don't really know. Most folks think because we're losing about the same number that we're gaining, that it is. We're just moving them over to the east. I don't think it's quite that simple, but I can't prove it in them wrong, and I don't think they can prove me wrong. But something that is certainly a climate change signal. We've seen this with hurricanes, and now Todd Moore, who's a researcher at Middle Tennessee State, and his colleague Tyler Fricker, who's at Louisiana Monroe, they've shown that the big days are getting bigger, and we're having fewer little days. And by that, I mean there are not many days anymore. Well, I should say not many. It's a decreasing rate of days where you have, in this case, blue, fewer than 9 tornadoes in a day. But the number of times you have a day with more than 20 tornadoes is going up. And those used to be very different. You'd have a lot more days with fewer than 9 than you did with greater than 20. But now they're almost equal, and they're going in opposite directions. So the point is, you either get nothing or you get a ton. And that is a very common climate change sort of signal in a variety of variables.
Why 9 and 20? Why are those the numbers?
That's an excellent question. I actually looked into that when he sent me that image. They were based on percentiles. So it was like I'm going to get this wrong, but greater than 20 was like the 90th percentile for tornado days, and less than 9 was maybe the 40th or 50th percentile. But yeah, good question. Also, if we want to mock the research of these guys, I'm totally okay with that. I mean, they're friends of mine, and we don't have to treat them with any high regard.
I don't know if I'm smart enough to make fun of it and then know what comeback is coming. I'm just trying to take it all in.
Yeah, and so Todd was really gracious. He helped me out here. I told him I was coming on here, and he actually sent me an image that is unpublished. It's in review right now. He didn't even tell me what journal it's being reviewed by, but it's just more of the same. So he looked 20 years from 1960 to 1980, and you can see where the hot spots were for tornado frequency, and you can see it was pretty much the Southern Plains, and there was a big absence. If you look at like West Tennessee and Kentucky, not much going on. There was still Mississippi and Alabama, and of course it's probably just due to reporting. Gradually, as you go through time, 81 through 01, starts to even out a little bit between the two areas, and then from 02 to 2022, you can see the Great Plains looks pretty empty, and just the map is lighting up over Mississippi and Alabama. So that's showing the trend spatially, and he's also showing it with that graph there where the blue line is the Great Plains, within that GP box he has on the map. And the red line is the southeast within that map, within that box on the map. And you can see the blue line is heading down, the red line is heading up. So this multiple researchers, and we haven't even shown them all, showing the same things. And that is that, yeah, whether it's a shift or not, the frequencies are certainly changing.
Yeah, I love numbers, and when they line up like that consistently over different research, I think it's pretty telling.
Yeah, that's how you learn. I mean, you shouldn't be swayed by a single paper, one research project. You're like, well, that's the answer. But it's kind of death by a thousand cuts. And in this case, the death is the thing that you used to think, and you're now learning a new way of seeing things through all of these different research papers. And that the last thing I put on here was just straight from SPC's website. And this is them now using the methods that all these tornado researchers have used over the last decade or so to plot the tornado events. And this is the top left one is all tornadoes, and you still see a bullseye there in northeast Colorado. You still see Oklahoma City, but of course you see that one through Mississippi up into North Alabama. Then they plot only EF1 or stronger tornadoes. This is a common way to do it because EF0 tornadoes, we really didn't have those. I mean, they existed, but we didn't record them prior to Doppler radar, and we were still pretty bad at it back then. But nevertheless, the EF1s and strongers, you see they're pretty much centered on the southeast. That's close to that image that Coleman and I created, Mississippi and Alabama being the bullseye. And this is largely due to the fact that if a tornado happens in western Kansas, there's not a lot to hit. I mean, unless it hits a high-tension power line or hits a town or something, it's hard to give it a high rating. I've seen some tornadoes out here in the plains that were unbelievably strong and scary to look at. You got to rate them based on the damage. That's the way the method is. And so you end up with much smaller ratings there. So I don't know if I totally believe that all the strong tornadoes are happening in the southeast. I think there are some stronger ones in the west too, but it's a damage indicator problem. And then, of course, it keeps going up. So the EF2 and greater, and then the EF4 and greater. And that EF4, you see those same little bullseyes pop up again. The one in Nebraska, the one in Oklahoma.
Right where I live, I mean, smack in the middle of that bullseye there for the EF4.
Lucky you.
I know, right? So that you were just showing, we've used that SPC before. I think it's interesting that this work done here, it shows that very early on that bullseye in Colorado, Oklahoma City. Just interesting to see that evolve and line up.
Well, the thing that kills me is it's like barbecue sauce. Everybody has strong feelings about different barbecues to the point that if they think Memphis is their favorite, then to hell with Kansas City and Texas and North Carolina. I don't even want to try those. My philosophy is I want to try all the barbecue, and I want to look at all the tornado maps. And just because I might have a favorite tornado map, which I don't, doesn't mean I'm gonna say that the other ones are worthless. Like, they're all telling a story. They're all creating a narrative that helps us understand more. Because the key is to learn from this and not be totally surprised when a tornado happens in southern Indiana and we're like, wait a second, that's not Dixie Alley or Tornado Alley. Like, no, it's they've been having tornadoes there for a very long time. The super outbreak of 74 impacted Indiana and Ohio as much or more than any other states. But for some reason, people have a relatively short memory on that stuff.
Well, that's kind of why we start talking about this, is because I think the public narrative, and I go to schools, and when I go talk to Rotary clubs or, a group of people that are older, they come at me with climate change. They come at me with geoengineering. They come at me with the shift of Tornado Alley. And the general, from what I've heard from people is there is that defined those two areas. And I feel like you just helped clarify that, no, not necessarily. You look at different levels. You look at the changing times, people being able to see these things. Everyone's got a dang smartphone, and there's a lot to consider. And honestly, walking away from this, I definitely have a different perspective. And I think being open-minded about anything like this, like you said, Grady, is like the best thing you could do, because there's always something we can learn. There's always something that, new information might come along and break something open.
Yeah, man, you said it. You got to pull them away as gently and lovingly as you can from the conspiracy theories where they think that the river or the mountain or the radio tower is attracting tornadoes or keeping them away or whatever. And you certainly don't want to think that the government is poisoning our people through contrails and all these other really outlandish conspiracy theories. So if you can show them some things to latch onto that are interesting and that are changing and they can follow, the changing in tornado climatology is an important one. Because if they start making that their hobby, they're making themselves safer in the process. That's wonderful. That's way better than arguing that, that we're seeding clouds to create 18-inch thunderstorms. That's not possible.
I think this.
We don't need that. We have bores that just come across. We have gravity waves that come across and just create 6 to 12 inches of rain. Nature has its own ways of blowing things up.
That's right.
Unnecessarily. So Grady, if you could, just kind of in summary, maybe assign order of magnitude in this perceived shift, just kind of like wrap it up. So someone's listening to this podcast, like what you think is the most important thing that they should know about this.
2 things I would say. 1, there is no such thing as Tornado Alley. And the people in the know are trying to get away from using that terminology. It is confusing and misleading, and it leads to surprises when tornadoes happen in places where they've always happened. So no more Tornado Alley. And the other thing is climate change is happening. It is happening in a variety of ways that are inconsistent and sometimes hard to figure out. It is affecting tornadoes, but again, not in ways that we really understand that well. And the Great Plains, I'm going to say almost no matter what happens with the changing climate and the shift or whatever to the east, the Great Plains are still going to have big days and big years. And we just had one. This year has been a very active tornado year, and it was in large part to events throughout the Great Plains. Was it last year? Maybe, or 2 years ago, had the same sort of thing. Big year.
2 years ago, definitely.
Yeah, so the plains are not dead, but and people get offended by that. They have some pride in their region having the most tornadoes or whatever, but yeah, plains are. I don't plan on taking my storm chase class to West Tennessee next year. I can promise you that. I want to still be able to see the tornadoes and have them moving at a speed where we can actually chase them safely. So yeah, it can be changing without disappearing.
Something you just said, just want you to elaborate on if you can, because this is another thing that people get really upended about. Is it global warming versus a climate change? You use climate change a lot, so give that some context when you're talking about this, if you can.
Yeah, absolutely. I mean, climate change is just a more precise way to describe the same thing. On average, the planet is getting warmer, but not every place is warming necessarily, and certainly not at the same rate. And actually, I got in the habit of saying that like 20 years ago because I lived in the Southeast most of my life. And from about, the 1850s through the year 2000, the Southeast was not really warming, at least not that much. Compared to the 20s and 30s, 1920s and 30s, the Southeast had been cooling. And that's part of the reason I don't think it's a partisan issue. I think there just happens to be a lot of people that identify as conservative that live in the deep South. And a lot of people that live in places along the coast that identify as liberal or Democratic or whatever. And they were experiencing different realities. Folks that lived in Alabama were saying, we've actually been getting cooler. And now that has shifted. Now, since 2000, all of the country is getting warmer. But climate change is just a more precise way of saying it, because there certainly are some areas still in the world that, due to things like modified El Niños and changes in snowpacks, which alter the way the jet stream goes, there are some places now that have become maybe more humid and slightly cooler.
Interesting. Thank you for clarifying that. That was perfectly said.
Oh, awesome.
Good professor would be. Is there anything else you want to just add to this as like the little cherry on top before I ask you a question?
I think that's a good place to stop it, man. I'm glad y'all are doing this. And I hope people respect that y'all, as their local experts, you're constantly seeking more information. And that's what we do. There's not, I've given talks to people 10 years ago, and they think that that's still the best answer. That what I told them. I'm like, no. Things have changed. Like, keep up, keep asking questions. Don't be ashamed to say you don't know or that you want to know more.
Absolutely. Love to learn. And you taught us a lot about this map. This is next week from a forecasting standpoint. Geopotential heights. These equate to roughly just shy of 20,000 feet up to 500 millibars. So explain to the folks out there why we look at a heights map to find an area where it's very hot.
Oh, should we start at the hydrostatic equation? Hydrostatic approximation?
Should we drive it? Should we just drive it?
The hypsometric. Ultimately, for a lot of weather processes, things move along pressure levels, levels of similar pressure. So we like to look at maps of, at the 500 millibar level, which doesn't mean much to a normal person. At the surface, it's about 1,000 millibars at sea level. And so as you go up, we have less air pressure. There's less air above our heads weighing us down. So 500 millibars is half of 1,000. You're about halfway through the mass of the atmosphere. And how do we tell differences, what's going on if we can't look at the pressure like we would at the surface? We look at heights. The height, really, just the heights above the surface. And if the air is thicker, then 500 millibars is higher above the ground. And the question is, why would it be thicker? And there's really two big things. If you heat something up, it expands, and you experience that. Like your fingers get bigger, your rings don't fit as well when you're warmer, your body is warmer, and also humidity. Like think about the door in your house might stick on really humid days, and so if you have more humidity in the lower half of the atmosphere, and if it's warmer, then it's gonna push that 500 millibar layer up, and then you can use heights like you would with pressure lines or isobars at the surface, and you can figure out which way the wind is going to blow. You can figure out where there are ridges, in this case, where it looks like kind of a rubber duck of heat risk.
So I outlined that and then realized after it looked like a duck. That's just where the 600 line is. Which is very anomalous, I feel like, for down here. I don't see that very often. That's why I outlined it. And then, yes, it's a duck.
Yeah, Western Kansas is not a cool place during the summer, but we don't ever get heights quite like that. So I'm grateful I'm not living in Memphis if this verifies.
Yeah,
it's the GFS. It's probably wrong. It's probably exaggerating.
Oh yeah, GFS. I grabbed this and there's a European somewhere, but yeah, GFS is out to lunch on its heat levels, man. But that's another thing. So
I thought you were going to ask him if a heat dome is a real thing. That's what I thought you brought this
up. I thought about it. I was like, well, if I go into that, I don't know how far down that rabbit hole we could get with the time that we have. I mean, I'd certainly broach that topic on another time. I mean, I'm sure there's a ton we could talk about. We discussed this, Grady, a couple weeks ago, and how it's not we said it's not a heat dome. So
I guess question becomes, what does dome mean? It's like alley. I guess when they talk about a heat dome, and the idea is that it is kind of peaked, and it's has a three-dimensional shape to it. If that's the case, then yeah, sure. I mean, your rubber ducky right here would be the peak of the dome, just because it has the highest heights, and it's driven largely by heat. But you're right. I think people probably misinterpret that term, and there's no reason that we need to hang on to it. It doesn't. I don't think it's instructive really at all. Is that kind of what y'all's problem with it is?
Yeah, so people equate it to, at least when I've talked to them, is like, you sit in a car and it's off, windows are up, and you just have this radiating heat effect, and it warms and it warms and it warms. That's what they're saying. When you talk about a dome, there's just like an exponential increase in heat throughout that entire area. It doesn't escape. It's yada, yada, yada. So
yeah, that can be tough. And there are certainly local effects over cities, for example, where you end up with inversions over the cities that might trap in pollution and stuff overnight after a really hot day. I mean, there's a variety of ways that people can misinterpret all the different ways that weather can hurt you throughout your life.
The urban heat island thunderstorms that Wes showed me, we'll have to reconvene and talk about that. That was one of the coolest things. It was one of those things where you'd seen it before, and I'd seen it growing up in Atlanta, but never connected the dots. Mm-hmm. And once you do, it's just fascinating.
Absolutely.
So did you put together the forecast competition for this discussion?
Oh, yeah.
Oh, look at that! Look at that! You got it.
So
you just wanted to show this with Grady still here that you beat me.
Grady, so I don't want to brag, but I'm on a bit of a hot streak. We do this. We just pick a random city each week, and we forecast for it and see who's closer. This was actually very close. We were a half a degree off, Wes. I was a little bit closer, and then you had no precip, and I was very close.
I didn't call for rain.
So I had the tiebreakers there. But
wait, hold on. We tied, and then I didn't call for rain?
No. I beat you by half a degree.
Okay. Okay.
But and then on top of that, that made me feel better about it because that distanced me further. I saw that 1/10 of an inch coming. You had no clue.
Was there anything tricky about forecasting in Minot?
Well, there was a cold front moving through.
Okay.
An Alberta Clipper. I mean, we were talking about temperatures in the upper 90s in the Central Plains. And up there, they had some raw data that was showing 49 degrees the morning of July 11th.
Wow.
Which that to me, not knowing the local kind of climatology there that you learn forecasting in one spot, I thought there's no way I could go 70. And so I went 74. Obviously verified at 70, that low temperature, 54. I mean, that's pretty cool.
54.
Wow.
So Grady, if you want to, if you're interested, we could be like a little guest for our next week. I picked this one. Don't ask me why. I was just scanning. I was like, this seems hard. Let's do a mid-Atlantic location that's influenced by the waters offshore, Chesapeake, Virginia, and we'll do it for July 25th. So, Grady, if you feel so inclined, you can send high-low precipitation to our email thread, and then we can.
I might have to do that. I don't know. My first thought was no way. It's been so long since I've forecasted for something like that, but I don't know. I was also going to share a strategy with you, but if I'm going to submit a forecast, I might have to keep that tucked in my pocket here.
Just grab the old Google AI or the Euro AI, plug it in, and there's
All right, I'll send you an email.
All right, we'll be looking for it. So, Grady, thank you so much for joining. I think this will be well received for people who want to learn because this does exactly what we wanted it to, and it's just to inform people. And someone who's done the research has seen all sorts of different types. This is great.
Thanks, guys. I'm enjoying just hanging out with y'all. It's taking me back to a decade ago, and I'm enjoying it.
Oh, thanks, Professor Dixon.
Hail State.